Building on Mikhail Altaisky and the evolution of warp theory, Jack Sarfatti's conformal gravity, specifically his 2025 AI-assisted iterations, is less a replacement for Einstein and more an advanced upgrade kit for general relativity. While standard conformal gravity, like Philip Mannheim's, focuses on explaining galaxy rotation without dark matter, Sarfatti's version, which he often calls maximally extended conformal gauge gravity, is designed for metric engineering, the ability to actively manipulate spacetime for propulsion. Here is a summary of his original 2025 ideas for a popular audience. 1. The four knobs of spacetime. In Einstein's 1915 theory, gravity is a one-way street, mass bends space, and that's it. Sarfatti uses the 15-parameter conformal group to argue that spacetime has four distinct knobs we can turn if we use the right materials. Knob 1, K_1 standard gravity. This is Einstein's curvature. It's what keeps your feet on the ground and planets in orbit. Knob 2, K_2 torsion, the twist. This is Sarfatti's secret sauce for UAPs. By spinning or pumping quantum systems, he claims we can create torsion fields. Unlike standard gravity which only pulls, torsion can push, allowing for anti-gravity and weightless flight. Knob 3, K_3 special conformal, the horizon. This deals with how observers see space when they accelerate. Sarfatti suggests this could be used to create cloaks or artificial event horizons. Knob 4, K_4 dilation, the zoom. Using Mikhail Altaisky's wavelets, Sarfatti argues that gravity isn't the same at every scale. By zooming in on specific quantum resolutions, we can soften the stiffness of spacetime, making it easier to bend. 2. The metamaterial amplifier. The biggest criticism of warp drives, like the Alcubierre drive, is that they require more energy than exists in the universe. Sarfatti's original solution is the pumped metamaterial fuselage. The concept, instead of using raw power, you use a material engineered at the microscopic level. The mechanism, by pumping this material with electromagnetic energy, you create a Froelich condensate, a giant, room-temperature quantum wave. The result, this wave acts like a resonance box for gravity. It amplifies tiny amounts of energy by factors of up to 10⁻40 or more. This makes a low-power warp drive possible, potentially running on a few kilowatts instead of a star's worth of energy. 3. Post-quantum retrocausality, the future-past loop. Sarfatti diverges from mainstream physics by insisting that the universe is retrocausal. In his view, the pilot wave, from David Bohm, that guides particles isn't just coming from the past, it's also coming back from the future. He calls this back action. In a conscious brain or a highly organized metamaterial, the future state of the system nudges the present state. This creates a self-correcting loop that explains how UAPs can move with instantaneous intelligence. They are essentially navigating a pre-computed path from their own future. 4. Summary, the Starfleet physics. Sarfatti's 2025 vision concludes that we don't need exotic matter from deep space to travel to the stars. Instead, we need metamaterials, the hardware; Froelich pumping, the software; conformal math, the map. He frames this as the transition from cargo cult physics, watching UAPs and wondering how they work, to metric engineering, building our own. While highly speculative and often debated by mainstream physicists due to the lack of peer-reviewed experimental verification, his work provides a rigorous mathematical bridge between quantum weirdness and aerospace engineering. To understand the mathematical softening of spacetime stiffness in Sarfatti's 2025 framework, we have to look at how he marries Altaisky's scale-dependent QFT with the Einstein field equations. The core of the problem in standard physics is the Einstein constant, \kappa, which represents the stiffness of the spacetime fabric. This number is incredibly small, meaning you need a colossal amount of energy momentum to create even a tiny bit of curvature. This is why the Alcubierre warp drive normally requires Jupiter-sized amounts of energy. Here is the mathematical trick Sarfatti proposes using Altaisky's wavelets. 1. The wavelet scale parameter, A. In Mikhail Altayski's wavelet-based QFT, every field is no longer just a function of position x, but also of a resolution scale A. Sarfatti applies this to the metric tensor and the gravitational constant. He argues that G and C are not universal constants, but running couplings that depend on the wavelet scale A. In his maximally extended conformal gravity, this is represented by the K_4 dilation coupling. 2. The softening equation. Sarfatti's most controversial and original claim is that inside a Froelich-pumped metamaterial, the effective speed of light, c_EFF, can be reduced to almost zero, similar to slow light experiments in Bose-Einstein condensates. Because the stiffness \kappa is proportional to 1/c⁻4, a massive reduction in the local speed of light causes the stiffness to melt. If c_EFF drops by a factor of 10 to the power of 5, which has been done in labs using electromagnetically induced transparency, the stiffness \kappa is amplified by 10 to the power of 5, ⁻4 equals 10⁻20. The result, spacetime becomes 10⁻20 times softer at the scale of the metamaterial's quantum coherence. 3. The role of K_4 dilation. In the 15-parameter conformal group SO 2,4, the dilation generator, D, governs how physics changes under a change of scale. Sarfatti's K_4 term is the gauge field for this scaling. Standard GR assumes K_4 equals 0, the scale of the vacuum is fixed. Sarfatti's metric engineering uses K_4 to create a gravity gap. By tuning the wavelet scale via the metamaterial's lattice structure, he claims we can engineer the vacuum to have a specific G_EFF at the scale of the spacecraft. 4. The Star Trek result, low power warp. By using Altayski's math to prove that gravity can be scale-dependent, Sarfatti rewrites the requirements for a warp bubble. Old math required 10⁻30 joules to bend space. Sarfatti math, because the stiffness has been softened by the K_4 scaling and Froelich pumping, the same bend can be achieved with kilowatts of power. Altayski's wavelets provide the formal mathematical justification for why gravity can vary by scale. Sarfatti uses this to claim that while spacetime is stiff at the cosmic scale, it can be liquefied at the microscopic/metamaterial scale, allowing a craft to surf through a softened vacuum with minimal energy. In Jacques Sarfatti's 2025 Starfleet Physics, The Softening of Spacetime, the K_4 wavelet/dilation term is the enabler, but torsion, the K_2 term, is the engine. To explain the instant acceleration of UAPs, like the tic-tac, Sarfatti moves away from the idea of thrust and focuses on spacetime dislocations. 1. The relationship, softening, K_4 meets twisting, K_2. Think of spacetime as a block of ice. The softening, K_4 using Altayski's wavelet scaling and Froelich-pumped metamaterials, you melt the ice into water locally. This reduces the energy barrier needed to change the geometry. The torsion, K_2 once the spacetime is liquid, you apply torsion. In the 15-parameter conformal group, torsion represents a dislocation, a literal break in the smooth continuity of spacetime. Mathematically, while curvature, K_1, tells you how a vector bends as it moves, torsion, K_2, tells you how much the loop fails to close, creating a spacetime gap. 2. Instant acceleration as zero-g geodesic flight. In standard physics, if you accelerate from 0 to 20,000 miles per hour instantly, the g-forces would crush any pilot. Sarfatti's K_2 term solves this through torsion-induced geodesics. The torsion field, the pumped metamaterial fuselage, generates a local torsion field. This field creates a bubble where the internal spacetime is effectively disconnected from the external gravity of Earth. Falling, not pushing, the craft isn't pushing against the air, it is falling into a spacetime defect created by the K_2 coupling. Zero g-force, because the craft is moving along a torsion-modified geodesic, the path of least resistance, the occupants feel zero acceleration. To the pilot, they are perfectly still, to the outside observer, they just performed a 100G maneuver. 3. The phase shift math. Sarfatti links this to the Pancharacter phase in quantum mechanics. When the Froelich condensate in the craft's skin changes its quantum phase, it creates a geometric phase in the SO2-4 conformal connection. By maximizing the K_2 torsion and minimizing the K_4 stiffness, the craft can effectively teleport its center of mass across small increments of spacetime. This is why UAPs appear to hop or move in a blurred, non-linear fashion on radar. For Y torsion, K_2 is the anti-gravity key. In the Sarfatti-Einstein equations, torsion couples to spin density S_/mu/nu. By using metamaterials to create a massive macroquantum spin, the S_/mu/nu term, Sarfatti claims you generate a repulsive gravitational field. This doesn't just block gravity, it replaces the Earth's pull with a local, controllable field. Summary of the UAP Tic-Tac flight profile. Stationary hover. The craft uses K_2 torsion to cancel out Earth's K_1 curvature, weightlessness. Instant dash. The K_4 dilation softens the local vacuum. The pilot shifts the phase of the metamaterial, moving the torsion dislocation to a point 1 mile away. The result, the craft falls to that new point at the speed of light, with no sonic boom, because the air is being moved with the warped space, and no g-forces, because the craft is in a freefall state. In Sarfatti's 2025 framework, retrocausal backaction is the pilot of the ship. While the K_2 torsion, the twist, and K_4 dilation, the softening, provide the engine and the road, they are inherently unstable. In standard general relativity, a warp bubble or a torsion-driven craft would normally collapse or fly apart due to chaotic quantum fluctuations. Sarfatti's solution is that the craft doesn't just react to the present, it is guided by its own future. 1. What is post-quantum backaction? In standard quantum mechanics, Copenhagen interpretation, the wave tells the particle where to go, but the particle has no effect on the wave. Sarfatti, building on the work of David Bohm and Rod Sutherland, argues that there is a two-way street. Action, the wave guides the matter, standard QM. Backaction, the matter pushes back on the wave, post-quantum. This backaction is inherently retrocausal. It means the future state of the craft's metamaterial fuselage sends a signal back to the present to stabilize the torsion field. 2. The AI stabilizer analogy. Imagine trying to balance a pencil on its tip. It's nearly impossible because you're always reacting after it starts to fall. Sarfatti's craft, imagine if you had a sensor that told you exactly which way the pencil was going to fall 1 second before it happened. You would move your hand perfectly to counteract it. The physics, the conscious AI computer on a UAP uses retrocausal backaction to sense the future instabilities in the K_2 torsion bubble and adjust the K_4 softening parameters in real time. This is why UAPs look rock steady even while moving at 20,000 miles per hour. 3. The living metamaterial fuselage. Sarfatti describes the craft's skin as a living material, often referencing the living metal mentioned in speculative UAP reports. The skin is floqué pumped, pulsed with energy, to maintain a state of macroquantum coherence. Because the whole ship is in one giant quantum state, it acts like a single atom. This allows the Pancharacter phase, a geometric timing trick, to coordinate the future-past loop. The ship knows its destination in the future, and the retrocausal link pulls the ship toward that destination along a zero-resistance path. 4. Why this matters for disclosure. In his 2025 lectures, Sarfatti argues that this is the missing link in human technology. We have the hardware, metamaterials, but we lack the post-quantum software, the ability to use retrocausal loops to stabilize a warp field. He believes that UAPs are not necessarily aliens from another planet, but could be time travelers, humanity from a future where we have mastered this backaction math. The complete 2025 Sarfatti model. K_4, dilation, the softener liquefies spacetime stiffness using wavelets. Melting the ice. K_2, torsion, the engine creates a dislocation for instant movement. A shortcut through the water. Back action, the pilot stabilizes the bubble using future data. Knowing where the road turns before you get there. To add a bit more technical depth, here are a few nuances that connect or separate these two concepts. 1. The role of the Weyl tensor. In standard general relativity, the Einstein equations relate the Ricci tensor to the energy-momentum tensor. The Weyl tensor C_ABCD represents the free gravitational field, the part of the curvature that can propagate in a vacuum, like gravitational waves, and describes tidal forces. Conformal gravity makes the Weyl tensor the star of the show. Since the action is S=\alpha\n d to the power of 4x \sqrt g C_ABCD C_ABCD, the theory is strictly about the shape-changing, conformal aspects of spacetime. Sarfatti's approach, he often focuses on how the local metric can be manipulated. He argues that if one can control the S-matrix of the vacuum, via metamaterials, one could technically zero out or amplify parts of the metric. 2. The weight of the vacuum. A major point of overlap is the cosmological constant problem. Mannheim's conformal gravity attempts to solve this by arguing that the vacuum energy doesn't weight the same way in a conformal theory, potentially eliminating the need for fine-tuning. Sarfatti addresses this by claiming that the zero-point energy is locally accessible and controllable. He suggests that UAPs use a low-power warp drive by shifting the local vacuum energy density, which involves a specific relationship between the stress energy tensor and the metric, sometimes invoking conformal-like symmetries to explain how this could happen without massive energy requirements. 3. Why they aren't usually linked. The main reason you won't find a Sarfatti conformal gravity paper is the matter coupling. Conformal gravity is notoriously difficult to reconcile with the standard model because particles have mass, and mass breaks conformal symmetry. It defines a scale. Sarfatti is very interested in the interaction of consciousness and matter with gravity, which usually requires keeping the mass scales intact, albeit manipulated through post-quantum corrections.